So sometimes we're not asked just to find the value of theta or just find the length of a side. We might be asked to find an exact value for sine theta, cos theta and tan theta. So to do that, they'll give us a triangle like the one that you can see here, and we'll start off by labelling it. So we know this is the hypotenuse because it's opposite the right angle. We know that this is the adjacent because it connects the right angle and the given angle together. And then that means that the remaining side is the opposite. So if it asks us to find an exact value of sine theta, if we go over to our formula triangles, sine theta is opposite over hypotenuse. So if we just look at our diagram, sine theta is opposite over hypotenuse, which in this case is 5 over 13. And that's the final answer. Obviously we can then do the same for cos. So if we go over to our formula triangle, cos theta is A over h. And so A over h, adjacent over hypotenuse, becomes 12 over 13. And finally for tan theta is opposite over adjacent. So the opposite is 5 and the adjacent is 12. So the exact value for tan theta is 5 over 12. Okay, so here we've got a second example. We've still got a right angled triangle. We've got theta here, we've got two sides, the only difference being we don't have the third side this time. We're asked to find the exact value of cos theta. So checking over at our formula triangle over here, cos theta is the adjacent over the hypotenuse. So if we label up our triangle as we always start, then we'll be able to get going. So here's the hypotenuse. We've got the adjacent connecting the two angles, and then we have the opposite. So just a reminder that cos theta is A over h. We've got the adjacent, but we don't have the hypotenuse. So we've got to think a little bit laterally here. How are we going to work out the hypotenuse exactly? Because it's got to be an exact trig value. So a good hint here, because we have two sides and we're trying to find a side, the thing that we can use to work out lengths of sides in right angled triangle is Pythagoras' theorem, a squared plus b squared equals h squared. So, as always, start any working with the formula that we're using, and in this case I'm going to call this a, that's b, and h for hypotenuse. So 4 squared plus 3 squared is the hypotenuse squared. We know 4 squared is 16, 3 squared is 9, and then if we do 16 plus 9, that's 25. And then because that gives me the hypotenuse squared, to get rid of the square, remember I need to square root. So the square root of 25 will give me the hypotenuse, and that answer is 5. So now I can go back to my diagram and I can label to say that the hypotenuse equals 5 centimetres. Now I'm at a position to actually find cos theta. So I jump back to my formula triangle. Cos theta is adjacent over hypotenuse. The adjacent is 4 and the hypotenuse is 5. Now the only thing to pay attention to at this point is that we're asked to give our answer as a decimal. So in order to do that, 4/5, we might want to convert that into another equivalent fraction, this time out of 10. And so we'd be multiplying the top and the bottom by 2. Remember, we always have to do the same thing to the numerator that we do to the denominator so that it stays equivalent. So the top gives me 8, so 8/10 is written as 0.8, and that's an exact value now for cos theta.